Hey guys, RLA Jack here for my second matrix video for MATLAB, and this video is going to focus on creative ways of building matrices, as there are several. So last little video I gave like a very explicit way of building a matrix. Specifically, I'm just going to call this first matrix A, and I just did like something like 1, 3, 5, 7, 9, 11, or 1, 11, 13, 15. I stuck that in a matrix, and I just gave it very explicitly. You write your rows first, and then separate each row by a semicolon, and you've got a matrix. But this is not the only way that you can build a matrix. There are commands that let you build special matrices. So if you want to build a matrix of just zeros, or well, perhaps it would be best if I first described what size is. So the size of a matrix is sort of a set of numbers. It's first the number of rows and then the number of columns. So if I do size of A, that'll give us the number of rows and the number of columns in a row vector. So this is 2 by 4. But we can also use other commands to build matrices of specific sizes to our specifications. So say we want to get a matrix of zeros, and we want it to be 2 by 4. We can run this command, and it'll make us a matrix of zeros that is 2 by 4. Also, if we want a matrix of zeros that is the same size as matrix A, instead of saying 2, 4, we could just ask, what is the size of A, inside our ask for a matrix of zeros. So we can do zeros of size of A, and surely enough, it will always build you a matrix that is full of zeros of the same size that matrix A is. So I'm just going to call this Z. Just like zeros, there's a command called ones, and you can do that as well. And additionally, there's this other command called randn, and it'll just generate a bunch of random numbers between 0 and 1, just like rand in the first video, which just generates a single number between 0 and 1. So those are 3 ways you can build matrices of very specific sizes. I think also randn works for normally distributed numbers, but I've never had to use that. So again, you can put a vector in here, anything. There are some special tricks. So if you put a just number in here, like 5, it's not going to generate you 5 numbers. It will generate a 5 by 5 matrix of numbers. So that's it for randn. And if you do zeros, it'll also do it. So that's sometimes useful. Another piece of very important matrix that you can make is called the identity matrix, or capital I, as it's called in much of your linear algebra information. But in MATLAB, instead of doing capital I, they use like the biological I, and it can make a 5 by 5 matrix by doing I of 5. I don't know. I don't really know why they would pick this, but sure enough, you could do that. And this matrix has some special properties with matrix multiplication. Namely that if you have a matrix of appropriate size and you multiply it by this identity matrix, it'll give you the matrix that you started with. So that's sort of it for building special matrices. But there's another kind of matrix, the vector, that can be built in some special ways too. So if you ever want to build a vector ones, you can always do something like ones, and if you want it to be a column vector of ones, you could say that you want it to be a 5 by 1 vector of ones. And surely enough, 5 by 1 matrix is just a column vector of length 5. And so you can do that. But there's also there are a lot of applications in mathematics for linearly spaced vectors. So we're like, you can go like have like 1, 2, 3, 4, 5. Well, more in programming, and this includes stuff like for loops and plotting, like sampling stuff. It's really quite helpful. So there's of course use for that in MATLAB, and that's called the colon. So you can do 1 and the colon and then 5. That'll give you a row vector of the numbers from 1 to 5, or of the whole numbers from 1 to 5. And if you do something like 1.5 colon 5.5, it'll actually also, give you this sort of unexpected result. It's not whole numbers. So actually, if you put just something colon something, it'll go from that first number to that last number, not exceeding the last number, spaced out by 1. So if you do 1.5 colon 5.4, it'll give you 1.5, 2.5, 3.5, and 4.5. Okay, so you can actually put something in the middle, and it'll space it out by that value instead. So if you do 1.5, and then 0.2, and then 5.4, it'll go from 1.5 to 5.4, or to the last value stepping up by 0.2 that doesn't exceed 5.4, and give that to you as a row vector. Again, this is of an indeterminate length, which sort of is a pain. So there are ways to get around this, and this indeterminate length, and it's called a linspace. But first, if you ever need a column vector of this, you can just use, I'm sort of jumping ahead to the next video, which is operations. You can use the transpose. So say you want a column that's 1 to 5 instead of a row that's 1 to 5. You can ask for a row that's 1 to 5, and then use this little apostrophe thing, the apostrophe, to transpose it. Surely enough, that'll give you a column vector. Whenever this would normally give you a row vector. But because this ends up not being of a known length, you sometimes want a certain number of samples between two numbers. So you can use a command called a linspace. What linspace does is it gives you a starting number and an ending number. Let's say I just want to go from 1 to 50. And you want 5 evenly spaced values between 1 and 50. You can type that in, and the first number is 1, the last number is 50, and these are linearly spaced between 1 and 50. As in, it's 12.25 between each of them. So you can use this for a lot of things. This is particularly useful for like drawing curves in MATLAB, which are just a bunch of line segments. But say if you wanted to replicate what we did for 1 to 5, we can do from 1 through 5 and have 5 samples, and there you go. You get 1, 2, 3, 4, 5. And of course you can also transpose what comes out if you need a column. But suppose you weren't wanting to go through all the math that's needed. Like say you need to go from -6 pi to 6 pi, and you want 1,000 samples. linspace will do that for you. And it really is the best way to build vectors like this. Colon expressions are good in some cases too, but for most of the things that you need MATLAB to do that you would use a colon expression for, linspace lets you sort of make sure that you don't have too many or too few samples to achieve what you want. Okay, so that's pretty much it for building matrices. In the next video, I'm going to be looking at manipulating them using the various operations on matrices. Okay, guys.